today's class. So, the topic that we are going to start today is a very important topic because this is sure to come for this SEM's first semester examination. Okay, so this was there in the specimen paper also. So it's a chapter based on derivative. It's a chapter based on derivative. The name of the topic that we are going to do today is called the name of the topic that we are going to do today is called L Hospital's theorem. It is called L Hospital's theorem. Okay, so everyone look at the board. So the topic that we are going to discuss today is L Hospital's theorem. Theorem theorem. So this particular theorem states that whenever the question is of the form limit x tends to a, that this particular value which you see is a constant number. So it could be 0, 1, 2, 3, pi by 2, even standard angles. So but 90% of the times you will see that this value is 0, but it is not necessary that every time it has to be 0. It can be any constant. Okay, so you will see one function in the numerator and you will see the other function in the denominator. So in class 11, you have learned that to remove the limit, we simply have to substitute the value of x, isn't it? We simply have to substitute the value of x. But in this particular type, when we substitute the value of x, see, on putting x equal to a in the denominator, you will see that on putting x equal to a in the denominator, you will see that you will get the question to be of the form, you will get 0 in the denominator. You will get 0 in the denominator. If you get 0 in the denominator, then the numerator will also be 0. So this is called a 0 by 0 form or an undetermined form. That means we cannot find the value of this. We cannot determine the value of this. That is why it is called an indeterminate form. Or if you get infinity in the denominator, then the numerator is also infinity. So these two forms which you see are called your indeterminate form. Once again, what you need to do is simply you put the value of x in the denominator. You will get two cases. If the denominator is 0, numerator automatically becomes 0. You don't have to check, it will be 0. Is that clear? And if the denominator is infinity, the numerators also will be infinity. So we cannot find the value of this. 0 by 0, 0 by 0 does not exist only. So that's why it's called an indeterminate form. That means the value cannot be determined. So whenever you get an indeterminate form, that means you have to solve it, isn't it? So whenever you get an indeterminate form, what you need to do is you need to apply L'Hospital's theorem. You need to apply L'Hospital's theorem. So L'Hospital's theorem is very easy. Applying L'Hospital's theorem means the limit will remain as it is. What is going to happen is when you apply L'Hospital's theorem, you simply have to differentiate the numerator. So the term which is in the numerator, you differentiate that, you will get f dash x. Similarly, differentiate not quotient rule. You have to differentiate them individually. Differentiate the numerator individually, differentiate the denominator individually. So you get g dash x. So what you are going to do is you are going to differentiate it one time. So you get f dash x. When you differentiate gx, you get g dash x. Is that clear? Now, once you have differentiated the function, now you have to repeat the same process. That means, again, put the value of x in the denominator. If the denominator becomes 0, numerator also becomes 0. Or if the denominator becomes infinity, numerator also becomes infinity. This is called 0 by 0 form or an indeterminate form. So we have to again apply L'Hospital's theorem. That means you are going to apply L'Hospital's theorem till you remove 0 from the denominator. The moment 0 gets removed from the denominator, you no more have to use L'Hospital's theorem. So everyone, those who joined late, especially for you all, what is L'Hospital's theorem? When you put the value of x, as a in the denominator, if you get 0 as the denominator, numerator will also be 0. That is called a 0 by 0 form. Or if you get 0 in the, or if you get infinity in the denominator, you'll get infinity in the numerator also. This is called infinity by infinity form. Both these forms cannot, the value cannot be determined. That is why it is called an indeterminate form. So since we cannot determine the value of this, we use the help of this particular theorem to find the value. So this particular theorem says you differentiate the function once f dash x, you differentiate the denominator once, g dash x, repeat the process. That means again put the value of x. If you still get 0, again differentiate. If you still get 0, you again differentiate. That means you have to repeat this process till you remove 0 from the denominator. Till you remove 0 from the denominator. So please take a screenshot of this.
Sir,
So please take a screenshot of this. Yes.
sir, you
Yes.
ALHTQ.
Applying L Hospital's theorem.
Yun siya.
Applying L Hospital's theorem. Okay, I'll rub this now. Now you'll see that the questions are going to be very, very easy. So I'll rub this. Okay. Now, everyone, please pay attention. So as I've already told you, you are surely going to get one question from this particular topic. So first question is to understand the concept properly. So number one, limit x tends to 0, 1 minus cos x divided by x square. Divided by x square. So put the value of x. Put the value of x in the denominator, not the numerator. Huh? Put the value of x in the denominator. What is 0 square? 0. So if the denominator is 0, numerator will be 0. You don't have to try, but just to explain it to you, I'm going to show it to you. What is cos 0? Cos 0 is 1. So 1 minus 1 is 0. So you are getting, when you put the value, you are getting 0 in the numerator and you're getting 0 in the denominator. This is called an indeterminate form because you cannot simplify from here. So the solution is possible only if you remove 0 from the denominator. So in order to remove 0 from the denominator, the L Hospital theorem says if the question is of the form 0 by 0, then we apply L Hospital's theorem. Applying L Hospital's theorem, it simply means that you have to differentiate the numerator and the denominator separately. So what is the derivative of 1? Derivative of 1 is 0 minus derivative of cos x is minus sin x. So minus into minus will become plus sin x divided by derivative of x square is 2x, 2 comes in front. So see, you have differentiated it once. Now repeat the same process. Put the value of x as 0. 2 zeros are 0. So if the denominator is 0, numerator is bound to be 0. So this is called 0 by 0 form again. So again applying L Hospital's theorem. So when you apply L Hospital's theorem, what do you get? Now 0 vanishes. So you're left with only sin x, isn't it? So you can just ignore this also because 0. So you can just ignore this. So derivative of 0 is, derivative of 1 is 0 and cos x is minus sin x. So minus into minus is plus. Okay, what is the differentiation of sin x, please? Differentiation of sin x is cos x. And what is the derivative of 2x? 2 is a constant, derivative of x is 1. Now you can easily see that now it is impossible for us to get 0 in the denominator because the denominator which we got right now is 2. That is no more you are going to get 0 by 0. So you need to stop. Is that clear? So the moment you remove 0 from the denominator, you need to stop. That means how would you, means now you need to solve it, means simplify. So simplify means remove the limit and put the value of x. So what do you get? Cos, instead of x we write 0 divided by 2. Cos 0 is 1 divided by 2 is the answer. So this is how you do L Hospital's theorem. So everyone look at the question properly because once you understand this, the entire question will be of the same form. So what we observe out here, an important observation is as long as there is x in the denominator, listen to me carefully, eh? As long as there is x in the denominator, you are bound to get 0 because the value of x is 0. So in other words, we are simply trying to remove x from the denominator. So the moment you look at the question, you will know that how many times you have to use L Hospital's theorem. So in this particular question, you see x square, isn't it? So can you tell me how many times should I differentiate x square to remove x. So obviously 2 times. How? X square got derivative. First is 2x. Then algebraic differential got derivative. 2 into x is 2 into 1. That means x has been removed. So that is how you come to know that you have to use how many times L'Hospital's theorem banera. Is that clear? So if the power is x, that means you have to use only once. If the power is x cube, if the power is x cube, then you have to use how many times? 3 times, because you have to differentiate x cube 3 times to remove x. So it becomes 3x squared. That's the first derivative. Next, 2 comes in front, so you get 6x, that is the second derivative, and 6 into 1 equal to 6, that is the third derivative. So I hope the concept is clear to everyone. So those who joined late, especially for you all, I'm going to revise it one more time. Then we are going to solve sums after sums. Okay. So the concept is same. So every time you get a question of the form u by v, a fraction, you put the value of x in the denominator, you will get 0 or infinity. If the denominator is 0, the numerator is bound to be 0. If the if the denominator is infinity, the numerator is bound to be infinity. This is called 0 by 0 form or infinity by infinity form. So once you know that it is an indeterminate form, there is a theorem which says that the 0 can be removed from the denominator by applying L'Hospital's theorem. And what is applying L'Hospital's theorem? You simply have to differentiate the numerator separately. Derivative of 1 is 0, derivative of cos x is minus sin x, so minus into minus is plus sin x, and differentiation of x square is 2x. So once you differentiate it, again repeat the process. That means this is the simplified function. Repeat the same process. When you put x equal to 0, 2 zeros are 0. You're still getting 0 in the denominator. That means we are still not done. So we need to differentiate it one more time. Derivative of sin x is cos x and derivative of 2x is 2. Now you can easily see that in the denominator there is only 2. That means 0 is not possible. So since 0, you are not going to get 0 in the denominator anymore, you need to stop. To stop, you simply remove the limit and put the value of x. Is that clear? Okay, so please take a screenshot of this. So this was question number 1. Okay, look at this question. Question number 2. This had come in your specimen paper, this year's specimen paper. The question was limit x tends to 0 log 1 plus x divided by x. It would not take more than 1 minute to solve this question, not even 1 minute. So everyone look at the board, look at the denominator, it's x. So how many times should I differentiate x to remove x from the denominator? You need to differentiate it once, isn't it? So that means you have to apply L'Hospital theorem only once. Now let us follow the procedure. Put the value of x as 0. So when the denominator is 0, numerator is bound to be 0. You can give it a try. 1 plus 0 is 1, log 1 is 0. So this is 0 by 0 form, or it is called an indeterminate form. We apply L'Hospital's theorem. So what is L'Hospital's theorem? Limit x tends to 0. What is the derivative of this? Everyone, log should always be with x, isn't it? So log x is 1 by x, but this is just an assumption. So I'll do it mentally. Derivative of 1 is 0 plus derivative of x is 1. So 1 plus 0 is 1. 1 into 1 is 1. So it is insignificant because you are getting 1. So when you multiply this term with 1, you get the same value. That's why I'm not writing it. Is that clear? Divided by the derivative of x is 1. So see, you have successfully applied L'Hospital's theorem, and when you successfully applied L'Hospital's theorem, you see that you are getting 1 in the denominator. That means no more 0 in the denominator. So this is it. Now just substitute the value. Remove the limit and put the value. What do you get? 1 plus 0 divided by 1. See, 1 plus 0 is 1. 1 divided by 1 is 1. 1 divided by 1 is 1. So the correct option is 1. So this is how you are going to get questions. Not that difficult, but you need to understand the concept. Is that clear? So once again, those who joined late, especially for you all, what does L'Hospital theorem mean? First, you have to check the form. Okay, you can apply L'Hospital only if it is 0 by 0 or infinity by infinity. The moment it's 0 by 0 or infinity by infinity, we apply L'Hospital's theorem. L'Hospital theorem means you simply have to differentiate the numerator separately, and you simply have to differentiate the denominator separately. Once you differentiate, then again you need to check. The moment I differentiated this function, I got 1 in the denominator. That means no more 0 in the denominator. So that this itself is my answer. So please take a screenshot of this. Come on, everyone. So please take a screenshot of this. Okay. So I'll just drop this. Okay, look at this particular question, everyone. Question number 3. This had come in this one. What do you call? ACS को आज एक्जाममा आएको थियो क्वेसन. कतिले गरेन होला. It was very simple. Limit x tends to 0, 8 to the power x minus 4 to the power x divided by 4x. Now you'll be able to do it very easily. Again, everyone, look at the denominator. There is only one x. That means in order to remove x from the denominator, I need to differentiate only one time. That means I need to apply L'Hospital's theorem only once. Because the moment x is removed from the denominator, then you are not going to get 0 in the denominator. The reason why we are getting 0 in the denominator is because of this x. Why? Because the value of x is 0. So come on, help me out. First, put the value of x. 4 zeros are 0. So if the denominator is 0, numerator is bound to be 0. If you don't believe, you can check. 8 to the power 0, anything which power 0 is 1. 4 to the power 0, anything which power 0 is 1. So 1 minus 1 is 0. So 0 by 0 form. So we apply L'Hospital's theorem. So applying L'Hospital's theorem, so you get limit x tends to 0. This is a direct formula. Formula number 3. What is d by dx of a to the power x? See, d by dx of a to the power x is a to the power x into log a. How did I come to know that I have to use this formula? Because the base is a constant and the power is x. So what is the formula for 8 to the power x? The formula is 8 to the power x into log 8 minus derivative of 4 to the power x. This is a. So the formula is 4 to the power x into log a. That means 4. Divide the whole thing by derivative of 4x. 4 is a constant and differentiation of x is 1. So this is the first function after derivative. Is that clear? Now everyone look at the denominator. Look at the denominator. What do you see? It is 4. That means no more 0, isn't it? That means this itself is my answer. Now just put the value. Everyone see. So 4 is in the denominator, comes out. So you get 1 by 4, open bracket. Put the value of x as 0. So 8 to the power 0. Anything which power 0 is 1. So 1 into log 8 will give you log 8 minus 4 to the power 0. Anything which power 0 is 1. So 1 into log 4 will give you log 4. And you know from laws of indices, sorry, laws of logarithm, log a minus log b. What is that? It is log a by b. That means minus changes to division. So 4 ones are 4 twos are. So which one was your correct option? 1 by 4 log 2. So you can see that all the questions that we are doing, the concept is remaining the same. So once again, those who joined late, this is L'Hospital's theorem. What you need to do is you need to put the value of x in the denominator first. So the value of x is 0. So 4 into 0 is 0. So if the denominator is 0, numerator will be 0. So this is called an indeterminate form because 0 by 0, the form does not exist. You cannot proceed from here. 0 by 0, 0 like 0 divided hudaina. So that means this cannot be determined. So in order to get the answer, we need to remove this 0 by 0 form. For that, we apply L'Hospital's theorem. Those who joined late, to apply L'Hospital's theorem, the question must be of the form 0 by 0 or infinity by infinity. Then only we can apply L'Hospital's theorem. So applying L'Hospital's theorem is very simple. You simply differentiate the numerator and the denominator separately, not quotient rule. Huh? Okay, so 8 to the power x is 8 to the power x log 8. 4 to the power x is 4 to the power x log 4, and derivative of 4x is 4 into x is 1. So once you have differentiated, now repeat the same process. Repeat the same process means put the value of x in the denominator. Since x is not there, this is 4. That means this can never be 0 again. So you have successfully removed 0 from the denominator. You have successfully removed 0 from the denominator. So once the 0 has been removed, you need not apply L'Hospital's theorem anymore. So you simply have to remove the limit remove the limit and put the value of x. So please take a screenshot of this. Okay, next question. Look at the next question. Limit x tends to 0 sin x minus x divided by x cube. So look at the board, everyone. Those who have joined late again. The power of x is 3, isn't it? That means as long as there is x in the denominator, it will be 0 because the value of x is 0. So to remove 0 from the denominator, we have to remove x. That is another way of understanding. So this is x cube. So I need to differentiate this how many times? 3 times. Because when you differentiate once, you get 3x square. When you differentiate twice, you get 6x. And finally, 6 into 1. So that means I have to apply L'Hospital's theorem 3 times out here. So everyone pay attention. Put the value of x 0. So this becomes 0 cube is 0. So 0 by 0 form. So applying L'Hospital's theorem. So you get limit x tends to 0. Simple derivative. Now please don't panic. Sin x co derivative is cos x co derivative is 1 divided by x cube co derivative is 3x square. Done. Now again repeat the process. Put x equal to 0. 0 square is 0. So 3 zeros are 0. Again, if the denominator is 0, numerator will be 0. So again applying L'Hospital's theorem. So what do you get? Limit x tends to 0, derivative of cos x is minus sin x, and derivative of 1 is 0, so you don't need to write that, and derivative of x square, 2 comes in front, so 3 2s are 6x. You're getting this. Now again put the value of x as 0, so 6 zeros are 0, so this is again 0 by 0 form. So applying L'Hospital's theorem, we get limit x tends to 0 minus, as it is, derivative of sin x is cos x and derivative of 6x is 6. Now you can easily see that in the denominator the x has vanished. That means it's a constant term. So you are not going to get 0. So the moment you realize that you don't get 0 in the denominator, that is the step where you have to stop applying L'Hospital's theorem. Now you just remove the limit. To remove the limit, just put the value of x. And what is the value of x? 0. So cos 0 is 1. So the answer is minus 1 by 6. So please take a screenshot of this. So please take a screenshot of this. And please do these all in your copy. So it'll be, so when you revise, the entire notes will be with you. And just don't keep the screenshots. Okay, now let us do a bit difficult type of questions. Okay, a bit difficult questions. This is whatever questions we have been discussing. This is page number 241. Okay, page number 241. You can try, in fact, all the questions from here. So the difficult ones I am doing. This is 5 subdivision 1, page 241. Page number 241. Question number 5 subdivision 1. The question is limit x tends to 0, e to the power x minus e to the power minus x minus 2x divided by x minus sine x. Now come on everyone, if you have understood the concept of L'Hospital's theorem, you will be able to do this very easily. Now what did I tell you? Put the value of x in the denominator. The value of x is 0, sine 0 is 0, so 0 minus 0 is 0. So you're getting 0 in the denominator, numerator you're bound to get 0. So this is 0 by 0 form. So 0 by 0 form. So we apply L'Hospital's theorem. So what do you get? Limit x tends to 0. Now differentiate the numerator and the denominator individually. Okay. So what is the derivative of e to the power x? Everyone knows e to the power x. Now this is minus x. That means in front of x there is a term that is e to the power mx. What is the derivative of e to the power mx? What is the derivative of e to the power mx? This m comes in front, so you get m dot e to the power mx. So the minus which you see, minus comes in front. So minus into minus becomes plus e to the power minus x minus 2, derivative of x is 1. So the differentiation of the numerator is complete. Differentiate the denominator, differentiation of x is 1 minus differentiation of sine x is cos x. So the derivative of the denominator is also complete. Now repeat the process till you remove 0 from the denominator. Put the value of x as 0. So what do you get? Cos 0. You already know cos 0, that was taught in class 9. Cos 0 is 1. So 1 minus 1 again becomes 0. So again this is 0 by 0 form. So I need to apply L'Hospital's theorem again. So when you apply L'Hospital's theorem again, what do you get? Derivative of e to the power x is e to the power x. What is going to happen to this minus sign? Minus sign comes in front. So you get minus e to the power minus x, and derivative of 2. 2 ones are 2. Derivative of 2 is a constant. So 0. Derivative of 1, 0. Derivative of cos x minus sin x. So minus into minus plus sin x. So we got this. This is the simplified form. Now again repeat the process. Put the value of x in the denominator. What is sine 0? Everyone knows that 0. So still we are getting 0 by 0 form. So applying L'Hospital's theorem, maximum is 3 times. Okay, maximum is 3 times. So when you apply L'Hospital's theorem, what do you get? Limit x tends to 0, e to the power x co-derivative is e to the power x. What is going to happen to this minus? Minus comes in front. So minus into minus is plus e to the power minus x divided by derivative of sine x is cos x. Derivative of sine x is cos x. Now for the last time, put the value of x. X is 0, but cos 0 is not 0, it is 1. That means we have successfully removed 0 from the denominator. That means this itself is your answer. So just remove the limit and put the value. Remove the limit and put the value. E to the power 0 plus e to the power minus 0, that does not exist. So it's going to be 0 only, divided by cos 0. Anything to the power 0 is? Anything to the power 0 is 1, plus anything to the power 0 is 1. So what do you get? You are going to get 1 plus 1 by cos 0 is 1. So the answer is 2. So the right option that you need to tick mark is 2. So go through this question, everyone. This was an ISC question. So page number 241, question number 5, subdivision 1. So you can easily see the question is limit x tends to 0, e to the power x minus e to the power minus x minus 2x divided by x minus sin x. So you simply have to follow the method that I have taught you. So the first thing you are going to do is you are going to put the value of x in the denominator. If you get 0 in the denominator, then the numerator automatically becomes 0. So this is 0 by 0 form, or we call it indeterminate form. What do we call it? An indeterminate form. So once you know that it's an indeterminate form, you need to apply L'Hospital's theorem. And apply L'Hospital's theorem mean you need to differentiate the numerator and the denominator separately. Is that clear? So once you differentiate it separately, then after you simplify, you have to check again. You have to check again. If you still get 0 in the denominator, then you have to repeat the same process again and again. Is that clear? So now let us do one a bit difficult question. So please take a screenshot of this. Come on, everyone. Please take a screenshot of this, everyone. So as you can see that if your basics on composite function is good, then questions like this are nothing. But if your composite function, the concept on composite function is weak, then you might have problems with this particular chapter also. That's why I took a lot of time explaining how to differentiate a standard function and a composite function. The video is still there. If you still have problems, you can go through it anytime. Okay, so another question.